All good? All right. So we also have my colleague Miran here with us today, who is an experienced SIEM and SOAR consultant, who will give a brief demo of the solution during the second half of the webinar. Now, what is the agenda for today? The challenges we'll be discussing today are like reported to be very common challenges across various industries. So I hope that regardless of the industry you belong to, the content of today's webinar is of valuable. I hope it provides valuable insights to you. And we'll then be looking at some traits that an ideal solution to these problems should be having. We will introduce you to a cutting edge data solution pipeline and how it may address the problems you're facing. And as mentioned earlier, my colleague Miran will at the end give a live demo showing how intuitive and easy it is to use the product that we'll be introducing. And lastly, we'll be having a bit of time for Q&A. While these questions will be answered during the Q&A sessions, please feel free to send your questions in chat at any time. Now, without further ado, let me jump into it. Now, the common challenges faced in modern IT environment. Compared to 20 years ago, 10 years ago, 5 years ago, there's been a massive growth in data generation, projected to be up to 175 zettabytes in 2025. With the increase in data, there's also an increase in requirement in compliance. There's a need to retain data for a long period of time, be it for compliance reasons, security, forensic reasons, or any other such reasons. And the average cost of data breach ends up being at around $50 billion. Now, there is also an increase in the tooling and the complexity it brings with it. There is a report saying that about 54% of the organizations have more than six monitoring tools. Now, if we were to consolidate these common challenges in the modern and IT environment, there is the explosion of data volume and variety. So, IT environments generate massive amounts of data from various sources, be it logs, metrics, traces. And with the rise of cloud environments, containers, microservices, and the volume and complexity of the data have grown exponentially, and that ultimately results in it being challenging to manage, process, and extract value from this data, especially in real time. And there is an increased cost of data ingestion and retention. Now, traditional solutions often charge based on the volume of data ingested. As the data grows, so do the cost for storing, managing, and analyzing this data. Now, this results in IT departments often needing to face increased expenses without a proportional increase in budget. There is a lack of control over data processing and routing. Different teams need different subsets of data, but many systems ingest all data into a single platform. Now, there's no easy way to route specific data to right systems or control what gets sent where. This results in unnecessary ingestion and wasted resources. There's absolutely overwhelming noise in data. Not all data is equally valuable. IT teams struggle with filtering signal from these noises. And sifting through these irrelevant data for insights is time consuming and can delay decision making. And then we have compliance and security concerns. Now, regulatory compliance often demands data retention, access controls, and auditable processes. Ensuring compliance while managing massive data inflow can be a daunting task, especially when working with multiple data sources. There are a lot of data sources in today's IT environment compared to several years ago. You have a lot of different types of sources. You have collectors, push, pull, TCP, UDP. Under them, you have sources such as Azure Blob, you have Grafana, you have TCP, and Elasticsearch, IPA, Splunk Forward. All of these various sources that give you data from different points of view. Like you get different insights from these sources, and you also have various destinations, each tailored for specific needs. You have your SIM, you have cloud storage, you have business analytics platforms, IT infra monitoring, log management tools like Elastic, Sumo Logic. You have Amazon S3, you have Splunk, Curator. Now, the number of sources and the number of destinations have been increasing quite a bit lately. That comes with its problem. It has, so we'll get to how it looks visually in the present modern IT environment. But look at the reality of data growth and the cost and complexity. Now we have a lot of sources sending data to a lot of processors, which sending data to either streamers or like the destinations directly. If we were to visualize this is what we call a data spaghetti. There's so much complexity involved in getting the between data sources and data destination. And the specific problems that come with such an architecture are as follows. Now we have observability data being very voluminous and it's very cost prohibitive. You like in the current day and age, it's not just about monitoring. We have observability, which focuses more on not just what the problem is, but also why the problem occurs. So obviously, the data needed to find out these problems, find out why the problems occurred, it's going to be massive, and that is becoming a problem. The vendor migration is cumbersome, making you logged into your vendor. So it's a tedious process if you were to consider other vendors and switch, because you'll need to change your so I mean, you'll need to first address the agents in each of the sources. You need to remove your old vendors agents, and then you'll need to put in a new agent for your new tool. So it is a complex process which takes a lot of time, forcing vendor lock-in. And sending only the relevant data to the tool of choice is difficult. Often, as mentioned earlier, the data gets sent as a whole to the entire destination. Even if you don't need like 40-50% of the data, it still ends up going to the destination and just staying there without providing any value. And data often needs to be reduced and it needs to be transformed before it's made usable. There are certain destinations expect your data to be in a specific format before it is usable. And not all data needs to be stored long term in the tool of analytics. So yes, there is retention requirements and there is like a need to store data long term, but it doesn't really need to stay at your tool of analytics. It can be at a different tool where it can then later be accessed. But instead, what's happening right now in most cases is all the data is getting sent to the tool of analytics, whose purpose is not to store data, it's more to do the analytics. But we tend to companies tend to use these destinations for just storage as well, which is not really ideal. And lastly, we have data duplication having a significant impact of cost. So let's say one set of data, 50% of it may be useful in one destination, 50% may be useful in another destination. So the same data is getting sent to both of these destinations, except same data is fully being sent to both of these. So in reality, there's a data duplication. You're sending the same data to multiple destinations, even though not all destinations fully utilize this data, and that is obviously going to have an impact on cost. Now, what this implies is that there is significant, there's exponential increase in data growth. There's 27% component increase in data growth, but the IT budget is linear and is simply not keeping up with the increase in the data growth. And if we were to approach the solution, let's look at some of the traits of an ideal solution. What is the solution for this problem that we discussed? What are the ways in which these problems can be addressed? Now, we looked at scale. We looked at the problem of data volume and variety. Now, there is scalability and flexibility that would help in addressing these problems. And then there is like in terms of scalability, like a solution that can handle massive data growths and accommodate various data types. It should be flexible enough to integrate with multiple tools and platforms, like such as cloud, on-prem, hybrid environments. And in terms of cost control, the solution must allow organizations to control costs by not only just ingesting and retaining the data, that it needs to truly add value. Like intelligent filtering should help avoiding ingesting irrelevant data while reducing expenses. And then we have noise reduction with data enrichment. So this is an ideal solution. I mean, trait that we are looking at. There is a lot of noise due to the increase in variety of data, and the solution should ideally, like instead of letting raw data flooding your environment, you need a solution that can transform, enrich, and reduce data volume before it reaches its destination. And we have customizable data routing, that is an ideal trait. Now, the ability to route data to the right place in real time, ensuring that each team or tool gets only the data they need. So this would address the lack of control over data processing and routing. And The compliance and data management. Now, a solution should help organize, meet regulatory requirements by providing fine-grained control over data access, retention policies, and auditable processes. So these are the various traits of an ideal solution to the problems that we had discussed in terms of the data volume, in terms of the overwhelming noise, in terms of the lack of control over data processing, the exponential increase in cost, and the compliance requirements. Now, what if there is a single solution that sits in between your data pipeline and it helps address each of these problems that we discussed? Now, that is Cribl. Let me quickly give you a brief introduction of the company before we jump into the specific, before we jump into how Cribl does the, how it tackles the problems, right? So, Cribl is a data observability company that provides innovative solution for managing and processing massive amounts of machine data. It is known for defining the market in the observability pipeline market for its vendor agnostic and hybrid cloud approach. It is a hyper growth company with 400 employees globally, and the founders bring in 30 plus years of observability experience. They have a strong leadership with experience in leading data, security, network, and B2B companies. They have solid financials with 300% year on year and about 400 million in funding. And they're obviously backed by leading companies such as Sequoia, Greylock, Tiger Global, etc. Now, coming back to the solution, the product itself, Cribl Stream. Now, Cribl is a unified data pipeline that gives IT teams full control over their data. It helps organizations reduce cost, manage data complexity, and optimize their existing tools and systems. Now, how does it solve these problems? Now, in terms of data ingestion control, Cribl allows you to filter out unnecessary data before it is ingested in your observability or security platforms, reducing the cost. It gives real time data routing. Cribl routes data to the right place in the right time, ensuring that only the relevant data reaches the platforms. And in terms of scalability, Cribl can handle massive amounts of data, scaling with your IT environment as it grows. And it enriches and reduces the volume of data, ensuring that only valuable insights are surfaced. And in terms of compliance, Cribl allows fine-grained control over the data, ensuring that it meets your regulatory and security requirements. Some of the unique features of Cribl includes agentless architecture. So it doesn't really need you to introduce a specific agent in order to get in the data. You have you can use existing agents already present in your sources and make it route the data to Cribl, and Cribl can then do its magic. It does the transformation, reduction, and everything that needs to be done before sending only the relevant data to the destinations. So it allows, it can transform raw data into enriched structured formats, thereby increasing the value this data provides at the destination. And Cribl works with a wide range of tools and platforms, both on-prem and in cloud. So looking at the value proposition of Cribl, and the specific use cases. So we have collect. Cribl can ingest data from a variety of sources such as logs, matrices, traces, and event data from cloud on-prem sources and hybrid environments. It acts as a centralized pipeline that captures all relevant data for processing, ensuring that no valuable information is missed. And next we have enrich. So Cribl allows you to enhance raw data by adding valuable context such as geolocation, and you have threat intelligence or metadata. This helps improve the usefulness of the data before it reaches your downstream tools, making analysis more efficient and insightful. And reduce. Now, Cribl enables this, by the way, is like one of the most common and like popular use case of Cribl. It enables organizations to reduce the volume of data by filtering out irrelevant and redundant information before ingestion. So this leads to cost savings and faster processing times, as only the necessary data is stored and analyzed in your destinations. And this can be in several forms which will be covered later. You can reduce data at an event level or at a field level. There's a lot of flexibility that Cribl gives in terms of modifying this data.
Manish,
And
before we move forward, we have
hmm,
a question.
yeah,
Can you please refer in chat box?
yes.
The question is, what do you mean by vendor agnostic
Hmm.
characteristic of Cribl?
Hmm. So when we say vendor agnostic, let me briefly move to the earlier slide. And we have various sources, and each of these sources may have different vendors, and each of these destinations may be from different vendors. There may be different choice of tools, right? Now, there's no one size fits all. Every company may have specific requirement, and they may choose specific products based on their requirements. Now, what Cribble does is that it seamlessly fits into this pipeline. It seamlessly fits into your existing infrastructure and gets data from various sources regardless of the vendor. So that's what we call vendor agnostic. The vendor doesn't matter. It can be any vendor. The data still can be routed into Cribble, and again can be routed to any destination regardless of the vendor. So that's what we mean when we say vendor agnostic. All right. Continuing on to the next use case, which is transform. Now, transform, a lot of destinations, as mentioned earlier, will require specific formats in which the data needs to be before it can provide value. Now, Cribble allows you to transform data into the desired format before it reaches the destination. This can involve reformatting, parsing, or restructuring the data to align with the requirements of the downstream tools and making it easier to analyze and interpret. Now, there is also one specific use case under Transform for data obfuscation. It is especially popular in finance and in healthcare industries, where you can obfuscate, you can mask or encrypt data before it reaches the destination. This enhances the security, considering the sensitive nature of the data, and you can also make it so that the right people are they still have the access to the encrypted data in the destination. So this will be covered later in the demo as well, but that is one popular use case for Cribble, like the data obfuscation before it reaches the destination. And the next use case is the routing. Now, Cribble intelligently routes data to the appropriate destinations in real time, ensuring that different teams and tools receive only the data they need. This reduces noise and optimizes the resource usage across multiple platforms such as SIEM, monitoring tools, or storage. So obviously, reduction is one major use case of Cribble, but the other use case is that by having lesser data for the destinations to process, you're reducing the load in the destinations. You're letting the destinations be a bit more efficient in terms of resource utilization, and Cribble enables that as well. And lastly, we have replay. Now, Cribble allows you to replay historical data from storage into the analytic platform for further investigation, compliance, or auditing purposes. This feature ensures that past data can be leveraged without having to continuously ingest or retain it in the live environment, providing flexibility and reducing cost. So what this essentially means is that you don't need your full data in your SIM, for example. You can send the relevant data to SIM, have a full fidelity data stored in a cheap storage such as S3, and when the data is required, you can just replay that data through Cribble to the destination of your choice. So in essence, you're having access to the entire data without having to pay for that the entire time, right? So let me visualize some of these use cases, right? Some of the popular use cases. Now, routing, obviously, let's say you have a set of data, you get the data into Cribble, and you can apply the reduction in Cribble so that only a part of the data is getting sent to your different destinations, and the full fidelity data is there at a long-term storage so that you can access it later. Cribble allows you this sort of flexibility in terms of against a single source of data. You can do what you want to do it with, and you have the freedom to modify it the way you want to modify before it gets sent to the various destinations. Next, we have reduction. Now, this is just an example of a law. Now, the highlighted bit is what's considered redundant or like not particularly necessary in the destination that we have here. So Cribble, what it does is it takes in this data, it removes the unnecessary bit. You have so much control over picking and choosing what you want and what you don't want. So based on your requirements, you can set it so that only specific fields remain before it reaches your destination based on what the destination is used for. Now, this is field level reduction. There's also another thing called event level reduction, where this entire event, let's say, for example, sampling, you can sample data so that you can send one out of, let's say, three, one out of five, one out of 10. It's up to you. It depends on your requirements. You can reduce the number of events that is getting sent to your destination. So in certain cases where it's where individual events provide lower value, but you still want some visibility over it. So in that case, you can have maybe only one out of five such events flow to your destination. So that is called event level reduction, and Cribble allows for both event level as well as field level reductions. And then we have the visualization for replay. Now, replay is basically data that has already been sent to your long-term storage, right? Like for example, Amazon S3. Now, whenever you need that data, you can simply, it is a very easy task to just replay that data through Cribble to the destination of your choice. So you don't need to store this entire data into your SIM or like any other tool long term. You can just have it in your long term storage, and based on ST, you can replay it through Cribble. And then we have data obfuscation, which I touched upon briefly. So there is masking, there is hashing, and there is encryption. Now, each of these can be done through Cribble. Now, masking, what exactly does it do? It Let's take a credit card number, for example. You have 12 digits. Now, with masking, you can just mask a certain part of the data, and so you can just mask it as such so that when it reaches the destination, no one will be able to see this content. Now, in terms of hashing, hash has like a specific, it is a specific string of unique, it is a unique string for specific files, or like these can be, these maintain uniqueness, right? So you can still be used for analytics without exposing the sensitive nature of these, and sensitive nature of this content, basically sensitive nature of data. And encryption is like, you can, it is not irreversible like hashing. Hashing is more irreversible. Once you do it, you cannot reverse it back. But in case of encryption, you can make it illegible. You can make the data illegible so that when it reaches the destination, people who shouldn't be looking at the data will not be able to look at it. It will be encrypted. But when you need to decrypt it, you can literally just, for example, in Splunk, we have a add-on for decryption of Cribble, basically. So what it does is, you can assign people so that only those people can execute this custom command to decrypt the data, so that the encrypted data can be decrypted in the destination. So that adds a lot of value in terms of the this thing, protecting the sensitive data. Now, moving on to a live demo, I'll hand it over to Miran, who will run through some of the, I mean, he'll give you a brief rundown of the GUI and some use cases. Now, over to you, Miran.
Thank you, Kumarish. Hi, everybody. Let me just jump straight into the demo. Okay, so we've been hearing about this term Cribble for some time, right? Let's look at what it feels like and what it looks like actually, and see what it can do in using a live demo here, right? So this is the landing page of Cribble, where we get to see what are the features and high-level introductions or high-level actions, and some highlights like pipelines and routes. We'll get there eventually, but this is just an overview page, right, where it shows a little bit of what Cribble can do, right? So basically, Cribble offers choices to route data, like my colleague here explained you very in detail, right? So it has a couple of options to basically connect the sources and destinations, right? Of course, the easiest is through quick connect. So quick connect just establishes the connection between the sources and destination, and it is only primarily used for testing purposes, right? When you're new to Cribble, or when you're doing some sort of testing to make sure that the data is coming into your destination and it is in expected format. So the easiest option is for you to visualize it through quick connect. But when you move the data or the configuration into production, then you have something called routes, which is highly customizable. And this picture actually depicts how routing basically works, right? So you can see the sources on the left hand, where sources of multiple sources like Windows, Linux, firewall, whatever it can be, that's coming through the pre-processing pipelines first, and coming into the routes, right? So this is where the routes are totally functioning, where it will apply some sort of pipelines which will have custom functions to run a specific action. For example, we just saw how the masking and hashing can be done, right? If we want to mask some data coming into this pipeline, there is a feature called function within Cribl that provides you an out of the box option to actually do that action, right? So this is how Cribl is processing the data, and once the processed data is coming into this post processing pipelines, that's when it decides which destination the data must go into, right? So then it goes and stores that, I mean, sends the data into the destination of the choice. So this is a high level picture of how Cribl routes work. Let's look at some of the features and some of the sources that are available out of the box in Cribl, right? So Cribl basically supports almost all of the different kinds of sources to collect data from, right? Be it push mechanism, be it pull mechanism, or if it is only using collectors. So we can see all of the supported data sources in this page. So starting from Azure Blog and Splunk collectors, you can see Splunk TCP here and Elastic. We have a raw TCP and raw UDP as well. Even for observability data like metrics and traces, we have something called open telemetry collectors. So and majority of Windows events can be collected through the Win event forwarders. We have options to pull data from Amazon SQS, Amazon S3, and event hubs. These are mostly basically used for high volume pull based data sources, right? And of course, there are some internal Cribl data collection mechanisms that are available to actually monitor how your sources and destinations are functioning. So now that we've seen what the data sources are supported, let's look at some of the destinations that are supported out of the box. Right. So by default, there are so many data sources that Cribl supports, starting from Splunk. You can send data to S3, you can send it to Azure Sentinel, you can send it to Google Cloud Chronicle, and Elasticsearch, and you can send to observability tools like Datadog and Sumo Logic. So all these data destinations are by default available within Cribbles itself, right? So you don't have to implement a new connector, or you don't have to use an existing out of the box or third party connector to establish the connection between Cribble and your destination, right? You can do it all here. So now that we've seen the data sources and the destinations, let's look at what is a pipeline, right? So how does Cribble handle the data sources, and how does it identify what functions to apply on the data sources before it sends it to the destination? So pipeline is nothing but an observability data flow, right, which will have a certain set of functions that will run on top of the data that is coming into that specific pipeline. You can have multiple pipelines for different data, and you can have multiple pipelines for same set of data as well, right? So you can apply different pipelines for the same set of data and perform different set of functions and send the data to different destinations also. So that sort of flexibility you get within Cribble using the pipelines and functions. So let's briefly look at what the functions will be. So some of the high level standard functions are basically to extract auto timestamp, or if you want to look up some data in your host name or something, if you want to do some DNS lookup, we can do that. And drop is nothing but how to drop a data, right? Whether you select an event level dropping or a field level dropping, which we saw sometime back in the slides. And we can also do a lookup to match and enrich some data, like my colleague here explained. We can also mask the data, the sensitive content of that particular data type, right? So you can parse it. All these are out of the box available standard functions. If I go to the formatters and advanced, there are I mean, there are other advanced functions that are pretty useful and probably customizable as well, depending on the requirement. If you want to customize the event breaker, for example, on where the event should break, right? Because in one of the earlier polls, there was a response that some of you guys are facing issues with data transformation, right? And again, event breaker is part of the data transformation. If you know where to break that event, you know how to transform that event, right? So you can customize that. And even for trimming, you have options to trim and unroll the data, right? So these are some of the functions that are available. So basically, functions are the actual actions that are performed based on preset configurations that you perform in that particular function, and that function gets added into the pipeline, right, for that particular data source. So if I just have to show you one of the pipelines that we have, so we have a lot of, I mean, I've created a lot of pipelines here for the demo purposes. Let me just go to one of the Windows pipeline that we have here. So if you look at this pipeline, I have almost 5, 6 functions here, which does a lot of things. If I just show you what it does, this is just a comment. And we have something called eval. So, I mean, the Splunk users will know what eval does, right? It basically gives you an option to evaluate using some condition and perform some action, right? So you can apply some eval commands and just make sure that you're replacing some of the sensitive information in the data, or if you want to apply some parsing to the data, we can do that using eval, right? So these functions occur in a sequential order, right? It goes, the data comes in this pipeline, it goes through each of these functions in a sequential order. First, it goes to the eval, and the processing will happen. Next, it passes down the event to the next function, and there will be a condition for each of the pipeline, sorry, each of the filter. So if for example, even in Windows logs, there will be several Windows event codes, like for example 4624 or any other event codes. So if we want to apply the functions based on only a set of the raw data, we can apply the filter here, so that the other data will still be processed as per your expectation, and the subset of that data will be parsed according to this particular function. We can choose the filter and apply the functions necessarily, right? If I just simply show you the function here, right? This is the raw event that I have. So we can actually, unlike other pipeline management tools, we can actually visualize how the data will look like before Cribl and after Cribl, right? So we have something called in and out here. So in is nothing but how the data will come into the pipeline. If I just show you the raw event, this is the raw event, and this will be the host, and there will be index and source types. But when this pipeline is applied on this source, how the data gets transformed is what will be displayed in the out column here. So if you look at this, there are several color coding, right? Each of that has a different meaning, right? For example, green means a new field was added to the data, and orange is nothing but some part of that event or data was modified using a pipeline, right? So if you look at this, the difference is evident here, right? So because it's like four and a half lines of event is converted into just a 2.5 line of events, right? Which means it is actually reducing the event and keeping the necessary field for your security use cases or your IT operations or business use cases, right? So I was talking about visualizing the data, right? We cannot, not only we can visualize the data how it will be transformed, we can actually look at the percentage of reduction as well here, right? If I just show you the percentage of reduction here, so the incoming data was around 105 kb, and the outgoing data was only 60 kb, right? Which means we got around 40% of reduction in one particular source. So imagine if you have almost I mean hundreds of GBs of data coming in from Windows, and if you want to reduce and apply reduction on top of that, imagine the cost and the storage that you will be saving for by using this. All right, so if I just go to one more, I'll just quickly show you how the masking and the data obfuscation happens, right? If I just go back to pipeline again, I have something to show you there. Let me open up that. Are there any questions, Vikash?
Yes, we have two questions from the Dolores Omri. The first is, we just want to know what security features Cribl offer other than masking and encryption that you talked about.
Hmm.
And the second question we have from Sakura is asking, can we perform searches in Cribl the same way we do it in Splunk?
Right. So I'll take the first question, right? So the security features, if you talk about, so Cribl is mostly, I mean, not storing the data, right? It just gives you an option to run some transformations in the incoming data, right? So apart from masking and encryption, you can do hashing, right, within the data. But again, it depends, right? So security use cases may require additional fields to be created or some part of the event to be dropped, or maybe if you have a requirement to only sample some of the events, like my colleague explained a little bit earlier, right? We can do all of those use cases based functions also within Cribl. It's not directly security feature, but of course it results in achieving your security use cases outcome. All right. So to answer the second question, we can perform searches in Cribl, just like we can do it in Splunk, but it's a different module that's not available inbuilt into this module, right? So the module that we are seeing is Stream, right? But we have a different module called Cribl Search, which is basically a data lake where you sort of store some data and run some searches on top of that, right? So, but again, since the data is not stored within the stream module, you won't be able to run searches here, right? It has a different module to run searches. I hope that the question is answered. All right. So if I have to move to the demo again, right? So I have four different functions here, and I'll show you what it does in a little bit. If I select the event, where is the credit card? Here it is. So this is the raw event I have, right? So I have, for clarity purposes, just to make things easier, I've created three different types of data and tagged it against three different indexes. The first one is hash, and second one is mask. Where it is, yeah. So the third one is encryption. Sorry, encrypt. So we have a mask as well. Just to show you how Cribl can help achieve a different set of, this different set of security features within the same pipeline. So if I go to the out, you can see the data has been transformed, right? For hash, so we are applying the condition for a particular field in the data. If I just go back here, each of these events has something called a CCN, which is nothing but a credit card number, right? So if you look at this, the raw data has a format which is actually human readable, right? Which is again a security violation if you are in financial industry, right? So this is the field that we are applying the particular function on, right? So if I go back to the out, you can see. Okay, I will show you this first. I'll show you how the masking works, right? If you see, the other data is not, is remaining untouched, whereas that particular format of data will be modified. So like I said, this is again a mask index where you can see the credit card number, the first 8 digits of that number is masked. The last 8 digit is visible, right? If I just comment this and enable the hashing function, it will be a slightly different result that we will see, right? Depending on whether you want to hash it, mask it, we can choose the functions necessarily. So if you look at this field, this is an hashing algorithm, right? So this is not basically masking, but this is changing the entire format of that field itself to make sure that the value itself is hashed completely using the standard hashing algorithms. And if I show you the third function, that is encryption, so we can see this is encrypted, right? So this is not, this is neither hashing nor masking, but this is more like encryption, right? If you want the data to be encrypted and not human readable, only if you use a specific function on the destination, you will be able to read this particular field, right? So depending on how your company's security policies are, security requirements are, the function will differ, right? If you have a strict stringent policy, then you'll probably go for hashing or encryption to actually mask the sensitive information. Right. So before I move to the last section of the demo, are there any questions?
Yeah, we have two questions in the chat box. The first is how Cribl can help organization comply with data privacy regulation like GDPR, CCPA, and HIPAA.
Right. So that's what we exactly saw here, right? So for all these privacy regulations, we have to mask the sensitive information that's available in the raw data, right? So a lot of the SIM tools like Splunk or SecureNX or Sentinel has this feature, but the data is still not masked when it is in transmission, right? So you will still be able to access the files, you will still be able to see the data live, right? The sensitive information. But here you can mask that information on the fly before the data is sent to the destination itself, right? If you have, for example, if you have credit card information or if you have health information coming in from a single source and you want that data to be sent to three different destinations, instead of applying the masking or the transformation settings on each of those destinations, it is easier for us to do it in the observability pipeline itself before the data is sent to the destination. So that's how Cribl helps organizations meet these compliance requirement. And if we move to the next question, how does Cribl performs the decryption of encrypted data? Right. Again, so it has to be customized, right? So right now the encryption and decryption is supported in Splunk because there is an app that is available in Splunk based to decrypt the encrypted data. But on the Exabeam or Somologic, the encryption and the encryption will be there, but the decryption will have to be customized depending on the security policies in that particular setup. All right. So if there are no more questions, I'll just quickly cover the monitoring part of it as well, right? Just to give you a hint of what Cribl's monitoring works like, how Cribl's monitoring works like, right? So we can see how the events are coming in and out of Cribl, and what is the throughput that's coming in, what is the throughput that's going out, and if you see the pattern, we can see if there is a drop in data, if there is a spike in data, right? All that information, and we can also access the resource utilization of the Cribl's stream node itself, right? We can look at the memory usage, we can look at the CPU, etc. We can monitor the Cribl for data incoming and outgoing as well as its own performance as well. I hope that was helpful. If there are no questions, I'll pass the mic to Kumaresh again.
Yeah.
Yeah, over to you, Kumaresh.
Thank you, Miran. So coming to the close of this seminar. So what's next? So a copy of this presentation will be shared with you, and the queries, any queries you may have, you can feel free to send to this email address. And please do visit our website for more details on Cribl, and you can also get certified for Cribl. Like you can, it's a very easy tool to pick up. You can, it is not difficult to pick up Cribl skills. So Cribl provides free education and training environment for like not just Cribl as a product, but also observability engineer certifications also provided in Cribl University for free. And you can also download Cribl and give it a try hands-on. There is a free version that you can download for like up to 1 TB of ingestion a day. Can be on-prem or cloud. And that is pretty much it. So thank you very much for joining the seminar today. I hope it was valuable insight, and I hope the problems that may be faced by you has been covered and how Cribl can help solve those problems. All right, so back to you, Vikash.
Yes. Before we close this down, we have a few questions. I want Miran to answer this. So, sir, one question is from Karthi. She's asking whether is this a log management solution? Cribl is a log management solution.
Right, Cribl is not directly a log management solution, right? But again, it can help your log management solution to make a better and efficient handling of your data. It's not a direct log management solution because it does not store any data, right? It just does the real time streaming of the data.
Okay. Then we have one more question.
How difficult it is to set up
Yes.
Cribl in our existing setup? It's very easy, right? And it's mostly UI driven, right? Unlike most of the other tools that are available right now in the market, because mostly those tools are configuration file based driven, right? But Cribl is very UI driven and it is very easy to install and set up. Even on prem and cloud, it's very easy to set up. What if I don't have a syslog server? Do I need to configure one to use the system? Not necessarily. So Cribl can actually collect data from your network devices directly. Cribl can act as a syslog server itself because it can collect the data from your network devices through a particular port that you configure. All right. So the last question is SNMP supported? Can I pick up SNMP traps? Yes, SNMP is also supported. We can send all kinds of data into Cribl, including SNMP traps. I hope the questions are answered.
Yes.
Right.
So we are on time also. So thanks everyone. Thanks for joining this particular webinar. And we will share the webinar recording and presentation deck shortly with you all. So once again, thank you very much for joining.
Thank you.
Thank you.